Okay, hi, I'm Bob Craycraft with the University of New Hampshire Center for Freshwater Biology. I'm the lab manager here, and today we're going to talk a little bit about the procedure for analyzing total phosphorus, the nutrient that tends to be limiting in freshwater systems, particularly up here in the Northeast, Maine, New Hampshire, Vermont area. It's a nutrient in fairly low concentrations. It stimulates growth in our lakes, so we're going to be going through a procedure to take a look at how we actually process those samples. And the first thing I will mention is when we get the samples, they arrive in a couple of different forms. And fundamentally, they arrive in 250 milliliter bottles, one of which I'm holding here. They come to us either frozen or refrigerated. For long-term storage, they're frozen. Shorter-term storage, they're refrigerated. And when we receive them, this one's still semi-frozen, we would put this into the freezer or the refrigerator until it's time to analyze. This sample is actually in the process of thawing, so it'll be analyzed fairly soon, in the next day probably. But we receive samples like this, and we have a bunch of them actually set out on this lab bench here, and we're going to go through and demo this preparation process, which is going to be several steps, so there's going to be several clips coming up. And what we have are the bottles set out here, and then we also have some glassware set out a little bit to the left, some Erlenmeyer flasks that we're going to pour the samples into, and a graduated cylinder, which is just a cylinder with gradations that we're going to measure out a specified volume of water sample into and pour it into these Erlenmeyer flasks. The idea behind this is to make sure the procedure is standardized so we get consistent results among samples that we process. Another key point I will mention is every time we pour samples out of these bottles, we do it in replicate. So there's two samples poured from each bottle. It's a way of looking at the precision or how reproducible our procedure is in the lab, making sure things are going well, getting a good yield for our clients. So as part of the process, what we're going to do is take one of our samples, and we'd have all this information that's on these labels from the respective lakes or streams these samples are coming from. These would be put onto a data sheet so we can relay the information from the bottles back to the measurements that we get through the analytical procedure. But we're going to be pouring samples out of these bottles, and again, we're measuring total phosphorus, which is all the phosphorus that's in this lake water. So it's both dissolved in the water as well as part of particles in the water, so algal growth, sediments, anything in the water. And to process these samples, what we're going to have to do is break down that phosphorus into one form that can be analyzed, and we'll talk a little bit more about that as we go. So the process involves using very clean glassware. So this glassware has been dipped in an acid solution to help remove any contaminants from the glassware, and then rinsed with highly purified water that we have in the laboratory here. So this glassware is highly purified. So we're going to take our water sample now, and again, since we're dealing with total phosphorus, we're dealing with particles as well as dissolved phosphorus. So we always want to make sure we mix the sample well before pouring it out. So I'm inverting it several times in advance. I'm going to take our graduated cylinder. Oops. Change hands here, make it a little easier to see. So take a little bit of our sample and pour it in here. I want to rinse this cylinder. Again, it's been cleaned with highly purified water, but it's always a good idea to rinse with a little bit of our sample in advance as well. Now, having done that, I want to invert again. Anytime I set this down, there is a possibility that things are settling out, so I'm just making sure things are homogenized in here. And I'm going to pour out 50 milliliters of water sample. Again, the cylinder has gradations. I want to make sure I pour out 50 milliliters. Oops, my hand's getting in the way, I apologize. So we've done it once. Again, I said we want to replicate that from each of these sample bottles. So again, I'm going to invert. Pick up our cylinder again. Pour out another 50 milliliter volume. Pour it out into our Erlenmeyer flask. So we now have that replicated, and we repeat this process for as many samples as we have here in the laboratory. And once we've gotten them all poured out, we're going to add a couple of reagents to these samples, because we're again converting the phosphorus from all its different forms into one form that we can measure on our analytical instrumentation. So we're going to do two things. We're going to first add a known volume of an acid solution. So I'm going to use a repeating pipetter for that. So I just pick up a known volume of acid solution. And what I do with that, just place it into our solution. This is a nice clean pipette tip. So I'm going to rinse first. And you will notice I'm using a waste container. We dispose of the hazardous waste in a specified fashion to meet federal and state regulations. But then I'm going to take our acid solution and add a known volume into each of the flasks that we have poured out. And what that's going to do is help release some of the phosphorus from some of the material in the flask. By changing the pH, it starts to release some of the phosphorus. And the second thing I'm going to do is take a known amount, this is a half-gram measuring scoop, a known amount of an oxidizing agent. Effectively, this will help disintegrate any organic matter that's in the samples. So I'm going to take a half-gram of that and place it in each of these flasks. And again, we're basically converting all the phosphorus to one form. And having done that, our next step is going to involve walking over to an autoclave, which effectively is a pressure cooker. We're going to place these flasks into that pressure cooker. It's going to help basically cook them for about a 30-minute period. And again, further break down that phosphorus and all that other debris in there, so we can measure the phosphorus that's in there as one single form. And I think now what we'll do is walk over to the autoclave and show you the next step.